in this example, it's a coffee cup calorimeter. And so when a 4.25 gram sample of ammonium nitrate dissolves in 60 grams of water in a coffee cup calorimeter, the temperature drops from 22 to 16.9 degrees Celsius. Calculate delta H in kilojoules per mole of ammonium nitrate. And we're going to assume that the specific heat is the same as water. So in a coffee cup calorimeter, we want to start by thinking about what equation we want to use, which is Q equals M C sub S delta T. And so I often talk about Q being this equation. If delta T is the same as water, we're going to make this negative. And so then we can start to look at what our constants are. So we have a mass, which in this case is going to be equal to 4.25 grams plus 60 grams, which is going to give us 64.25 grams total because it's the entirety of the water. So C sub S in this case is going to be 4.184 joules per gram Kelvin. And so delta T in this case is going to be final, which is 16.9 minus 22, which is going to give us negative 5.1 degrees Celsius. So when we plug this into our calculation, we have Q equals negative 64.25 grams times 4.184 joules per gram Kelvin times negative 5.1 degrees Celsius, which is also the same as Kelvin. So when we plug this into our calculator, we can type in negative 64.25 times 4.184 times negative 5.1, in which case we get, that Q is equal to 1370.99 joules. So this is the heat change for this type of sample. However, the answer is asked for in kilojoules per mole. So we can easily convert this to kilojoules by dividing by 1,000. And so we get 1.37099 kilojoules. Now, this is kilojoules per your sample, which is 4.25 grams of ammonium nitrate. We need to convert that into moles. So in this case, we also need the molecular weight, which you would take from your periodic table. And so it is 2 times 14.01 for nitrogen plus 4 times 1.01 for hydrogen, and then plus 3 times 16.00, and that's for oxygen, which gives us 94.07, to run out of space, grams per mole. We need to convert our sample from the problem into moles. So we're going to take our 4.25 grams, divide by 94.07 grams in 1 mole, which, when we plug that into our calculator, is 0.045179 moles. So now we can come back up to here. So Q equals delta H at constant pressure. And so we derived this equation in class, and so we can also just remember that Q at constant pressure is equal to delta H. So we can now take our Q value of 1.37099 kilojoules and divide this by our quantity of moles, which is 0.045179 moles. When we do this, we get that delta H is going to equal 30.3458 kilojoules per mole. Feels like we have way too many significant figures. So in our problem, all of our values have just 3. So we can convert this to 30.3 kilojoules per mole of ammonium nitrate.